The cosmic microwave background is supposedly the remnant of the Big Bang, and it's radiation that's been stretched over a period of 13.8 billion years, which is the alleged age of the Big Bang universe. And so the temperature was very high, they say, and now it's very small, down to about 2.725 Kelvin. As the space-time is stretched, the radiation is stretched, and the temperature drops, so they say. But it's a scientific fact that the so-called cosmic microwave background mean temperature of the universe has never been detected beyond 900 kilometers of the Earth. It's never been detected anywhere else. It's been detected from the ground, and it's been detected from about 900 kilometers by a satellite, the Kobe satellite. The other satellites, such as the Planck satellite and the WMAP satellite, are located at a place called L2, the second Lagrange point, which is 1.5 million kilometers from Earth. Well, at that place, no microwave mean temperature, or what's called the monopole signal of the microwave background, has ever been found. It's never been reported that they've detected it. Certainly WMAP couldn't do it because of the nature of the instrument. It was incapable of detecting it. It was a differential instrument. But the Planck satellite was capable of detecting and taking an absolute measure. It never found it. It never reported it. You think if the cosmologists found it, they would not have reported it? Of course they would have done. But they haven't done. And the reason is that the signal that they have is from the Earth. When Penzias and Wilson in 1964 observed from the Earth, from the ground, they looked into the sky in all directions, and they had a residual signal in their antenna, and they supposed that it was from the cosmos. Well, the theoreticians heard about it, and in the very same issue of the journal, in a paper appearing immediately before Penzias and Wilson, the theoreticians, they proposed that this new finding was cosmic from a Big Bang fireball. But the fact is, it's a very simple solution here, is that if you take a glass of water and you put it in a microwave oven, you turn it on, the water gets hot because it absorbs microwaves. Now we know from the laboratory that anything that's a good absorber is also a good emitter. So water is a good emitter of microwaves. Radio communications engineers know that if you want to communicate underwater by radio, you can't use microwaves because the oceans absorb the microwaves. So submariners know that. They use long radio waves to be able to do this. So we know again that water is an absorber and hence an emitter of microwaves. Well, about 70% of the surface of the Earth is covered in a lot of water. And that water is not microwave silent. And 900 kilometers is not far from Earth. So if you put a satellite up at 900 kilometers with a shield that's pretty poor, in fact, impossible for it to protect itself from its instruments from microwave diffraction over the shield, which is exactly the situation with the Kobe satellite. Microwaves from the oceans go into the atmosphere, they get scattered. Because they're scattered by the atmosphere, it becomes more or less an isotropic bath. So from the ground, no matter which way you look, it all looks the same. And at 900 kilometers from Earth, it doesn't matter which way the Kobe satellite was pointed because the radiation from the Earth diffracted over its shield and straight down into its instrument. So so this is not a Big Bang scenario. They measured the Earth. They didn't measure the temperature of the universe, right? So without that, though, their theory is in tatters. Well, they haven't got it. So there are two counts for it now. These simple facts and the fact of Kirchhoff's law for thermal emission and that Planck's equation is not universal. So without that, there is no Big Bang cosmology. So in this explanation, we don't even need an equation from general relativity. But of course, general relativity itself is inconsistent, so it doesn't work either. So that's the theory from which this Big Bang cosmology was obtained. Well, the theory is no good either. So there is no Big Bang. Well, they did that for a long, long time with the gravitational waves, 40 or 50 years or so. And they never found anything. And now they've all of a sudden found three. 3 sets of gravitational waves produced by 2 black holes merging to form 1 black hole. Well, it's not possible. And the precision of their measurement is certainly eyebrow-raising. How can you measure 1,000th the diameter of a proton, as they say they did, which is a related issue, but it really doesn't matter because they certainly didn't measure black holes, and they certainly didn't get gravitational waves. These things do not exist. And so it's not science either. The search for gravitational waves and black holes, this is now getting even more extreme, with India now being, or seemingly to commit itself to the construction of a LIGO device, other nations to contribute to the development of the LISA system so that there'll be space-based satellites or to enable even longer interferometers for the search for gravitational waves and black holes. They've maintained now for a while that they've had 3 incidents of discovering binary black holes producing gravitational waves detected with the LIGO system in Hanford and Livingston, but these things don't exist. And black holes certainly don't exist. They have impossible properties, and they're products of violations of the rules of pure mathematics. So it's a combination of impossible things. Well, I don't see any reason to believe that the universe has a beginning or an end. There's nothing scientific to indicate that to me. So as far as I can tell, there's no reason to believe we've got a beginning or an end. How it works, who knows? It might even be a question that science can never answer. There are things that science cannot answer, and maybe this is one of them. Well, physics is an experimental science. The theoreticians with their mathematics, and this is all just somewhat game playing. Ultimately, it's experiment in physics. And I haven't seen any experiments that indicated in any way at all that gravity and electromagnetism are one and the same in some way, somehow one and the same thing. So without experimental evidence, one can hypothesize and assume certain ideas. You can do that ad infinitum. So I try to be guided primarily by physical reality and not to augment things with ideas that are not soundly based in the experiments, because it can be done easily. People do it all the time, and there are lots and lots of different theories, but they don't have a real basis in reality. So I minimize my hypotheses for that reason. So I don't see any evidence, in the end, I don't see any evidence for electromagnetism and gravitation being unified. This is an idea that Einstein was obsessed with, and his followers have been obsessed with, unifying gravity with electromagnetism. Well, they're trying to unify gravity with quantum mechanics. And it seems to me that there's no experimental basis for it at all. And it's just hypothesizing, making up ideas and playing around with equations. So for me, that's unsatisfactory. It's not really sufficiently scientifically based.